This is a help me video for the Key Assessment 3 Resit. Question 1. High blood pressure in humans can be caused by a polypeptide called angiotensin. So polypeptide or protein. Never heard of that name before, don't worry about that. And it's produced in one form called angiotensin 1, converted to another one that's active called angiotensin 2, and there's the enzyme. So in any enzyme experiment, it's usually useful to identify the enzyme, the substrate and the product. So we got, that's our substrate, that's our product there, and this is our enzyme there. The enzyme removes 2 amino acids from the end of the angiotensin 1. So a polypeptide is a chain of amino acids, and these have different R groups sticking out. Okay, and the enzyme removes 2 amino acids off the end, so the enzyme cuts 2 amino acids off the end. Now, removing the amino acids makes the angiotensin 2 able to bind to receptors. Suggest how? Well, this is the primary structure of a protein, and if you remember your protein structure, these R groups can attract each other. So this R group here might attract that R group, and that might bend and fold in a certain way. This R group here might attract that one, and it might be an ionic bond, a disulfide bond or something like that, and that will make the chain fold that way. If we remove this, then that R group isn't there anymore, so it won't fold, so it'd be a different shape. So the answer here is, tell us, which sort of level of structure of the protein is going to be changed, and you need to talk about shape to bind to receptors. It's all about the kind of that complementary shape. Part B, it's telling us a drug called April, never heard of it, treat high blood pressure. It's an enzyme inhibitor. Right, okay, it's an inhibitor. So now I'm thinking about all the inhibitors topic, and we've got a graph here. This is concentration of angiotensin 1, that's our substrate, and this is the rate of reaction, and this is our with the inhibitor, and that'll be our normal reaction. So now, using the graph, so we need to do this using the graph, explain how, okay, I still can't say enalapril inhibits A. So how does the inhibitor inhibit the enzyme? And if we asked you that any normal day of the week, you'd talk about competitive inhibition or non-competitive inhibition and be able to talk of those. You need to identify which one it is, and the clue there, especially when it says using the graph, is that if we increase the concentration of the substrate, these two lines eventually will meet. So the concentration of the substrate has an effect, and it only does that with one type of inhibitor. So name the inhibitor, the type of inhibitor, and how that works, and then give us this information here. Well, look, it's affected by the concentration of our substrate. Explain how enalapril reduces high blood pressure. Well, we don't know how this works, but it's got to be something to do with this inhibitor. So if it inhibits this less angiotensin 2, and that gives you the high blood pressure. So it's got to be, we're making less of this product, and it's just going back to the stem of the question there. Over the page, the rate of an enzyme catalyzed reaction is affected by temperature. Explain how. Right, bingo, 6 marks. So we've got our normal graph for temperature, and this is the rate of reaction, and it goes up like that, and then it kind of goes down, and we've got our optimum temperature there in the middle. So the marks here are for explaining what's going on there. So as we increase the temperature, what's going on, and then as we increase the temperature further past the optimum, what's going on. And we need, what's happening to the actual particles and the energies and things like that, and we might mention bonds and the name of these processes. So that's straight from your notes, is that section.